See the next theorem, perpendicular bisector theorem, part 1. What is the statement? Every point on the perpendicular bisector of a segment is equidistant from the end point of the segment. So what is the given? The line L is a perpendicular bisector of segment AB. This is the segment AB and this line is a perpendicular bisector. So this line is a perpendicular and bisector also. Here they prepare a 90 degree and this AB divided into two equal parts. So to find P is a equidistance from A and B and PA equal to PB. PA equal to PB. This we find out. Now this perpendicular bisector divide this triangle into two small triangle, that is triangle first, triangle PMA. This triangle PMA and triangle PMB. Okay. Now in this triangle here the PM is a common side. So we write here segment PM. Here we write statement number 1. PM congruent segment PM common side. Okay. Then second, that is a angle PMB and PMB. This 90, this also 90 because perpendicular. So angle PMA congruent angle PMB, that is each 90 degree. Okay. Now next one, that is AM and MB is a congruent because given in our example. So here segment AM congruent segment BM. This is the given. Okay. So these three tests our is of successful. So these two triangles are congruent by test. This test SAS, side angle side. So we write here triangle PMA congruent triangle PMB. So SAS test. So what is the next? What to prove? That is PA equal to PB. So here the segment PAPB congruent because corresponding side of congruent triangle. Therefore segment PA congruent segment PB. Right here CSCT. Therefore length of PA is equal to length of PB. This is our part 1. Now see the second part of this perpendicular bisector theorem. So what is the statement? Any point equidistant from the end point of a segment lies on the perpendicular bisector of the segment. So any point means point P. Here point P is equidistant from end point of segment AB. This is the segment AB and this is the point P. So what to prove? That is point P is perpendicular bisector. So this is the perpendicular bisector of this segment AB. So now what is the construction? Take midpoint M. This is midpoint M of segment AB and then draw this line PM. So for this line we get this two triangle. So in triangle PAM and triangle PBM. Okay, in this two triangle there is this segment and these segments are equal. That is given in our theorem. So segment PA congruent segment PB, that is given. Okay. Now what is the next? That is segment PM. This segment PM is a common side. So this also congruent and here AM congruent MB because M is the midpoint. So that also congruent. Therefore segment AM congruent segment BM, that is M is the midpoint of segment AB. Okay, and third one, that is segment PM congruent segment PM, that is common side. So our three conditions are here formed. So these two triangle are congruent by S side, SSS test. So triangle PAM congruent triangle PBM for SSS test. Now what is the remaining part? That is in this here PMA and PMB. This is the perpendicular bisector. So these angles are congruent. So remaining angle, that is angle PMA congruent to angle PMB. This angle, that is corresponding angle for congruent triangle. This is the 90-90. So here angle, now these two angles, that is this type of angle, that is a linear pair. So addition of linear pair angle is a 180. So PMA plus angle PMB is equal to 180. Here write the angle in linear pair. Okay. Now here see here angle PMA is equal to angle PMB. Therefore I write here PMA plus, here in this place PMB, I write here angle PMA. So 180. That is from our statement number 5. So PMA 2, angle PMA is equal to 180. Angle PMA is equal to 180 upon 2. So angle PMA is equal to 90 degree. So therefore 90 degree. Therefore segment PM is perpendicular segment AB, because here 90 degree. Therefore segment PM perpendicular segment AB. But here the M is the midpoint of segment AB. Okay, in construction. So I write here last statement, that is therefore line PM perpendicular bisector of segment AB. So therefore point P, last statement, our point P is perpendicular bisector of segment